Hi, welcome to P7.2, Demonstrate an Understanding of Equations and Expressions by figuring out the difference between an equation and an expression, evaluating, which means solving, so there will be an equal sign, and verifying solutions to equations. So we should know what a variable is. That's anytime you don't know what a number is, you would use a letter. Most commonly we use X, Y, Z, sometimes A, sometimes B, sometimes P or Q. We don't usually use L because it looks like a 1. And they don't use O, obviously, because it looks like a 0. So sometimes you'll see variables. Sometimes they even use Greek letters like theta. And if you are solving a word problem and it says, what is blah, 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 you can substitute some math in for that English sentence. Anytime it says what, you know that that's the variable. Is means equals, and then you can solve your problem over there. Okay, the next indicator says provide an example of an expression and an equation. Explain how they're similar and different. I have that coming up for you. How to evaluate an expression, which means solve. How that result is different from a solution to an equation. So evaluate could be that there might be a greater than or less than sign, so that would be an inequality. And it could be that you have to reduce or gather like terms. Verify a possible solution to a linear equation using substitution. Explain the result. All right, here we go. So here's a little math humor for you. So we're always solving for x, so the instructions here, find x. The student says, oh, it's right there. And good old Keanu Reeves down here. What if algebra teachers are really pirates and they're using us to find x so they can find the treasure? So x could also be a picture, right? Nemo divided by 3 equals 2, so Nemo must have been a 6. So a variable is just an article or an item that we substitute in until we can figure out the number. If you think of an equation like a balance scale, let me just change my pen here. The middle of the scale is your equal sign. So if you have x on one side, and we've got 4 coins over here, so x is 4. Well, if I add something to one side of my scale, I need to add something to the other side of the scale. They have to match. So whatever you do to one side of your equation, you must do to the other. If you divide the whole thing by 2, you must divide the whole thing by 2. If you square it, you must square it. Okay, so just always think of that balance scale when you're doing equations. So I love this diagram because it explains pretty much every operation. So operations are plus, minus, multiplication, and division, and how to keep your balance scale even. Okay, so if this is your equal sign, your whole mission in life is to get the variable, which is the y, naked and alone with nothing else. So down here you can see they've got the y all by itself. There's nothing else with it on that side of the equal sign. And so what they did to get rid of the 14, if you have a plus 14, well, the opposite is minus 14. And so these two cancel out, right? Plus 14 and minus 14 is 0. But what you do to one side, you must do to the other side. So they did 20 take away 14 and got 6. Their y was naked and alone, nothing else on its side of the equation, and they got a nice single number answer over there. Okay, let's look at the green one. X minus 120 equals 80. So some number that we don't know, if you took away 120, it would be equal to 80. And so we're going to add 120 to both sides because the opposite of negative 120 is positive 120. So we've gotten rid of that whole chunk, and the x is all by itself, naked and alone. But what you do to one side, you must do to the other. And so they've added 120 to this side as well, got 200. In the purple example, the n is being multiplied by 3. This is basically 3 times n, right? They just didn't use the brackets. So the opposite of multiplying is dividing, and they've used a fraction bar right there. They divided by 3 because you have to think about poor n, he's being multiplied. What do I wish I had on the bottom so I could get rid of the variable? Well, I wish I had a 3, and those two cancel out, right? You're left with just your n, naked n alone. But if you're going to divide by 3 on this side, you better divide by 3 on this side as well. And they've given a little explanation here. 3 over 3 cancels down to become 1 over 1, which is 1. So anything over itself is 1. So anytime you have a variable like 5x equals 20, what do you wish you had on the bottom so that you could get the x naked and alone? Well, I wish I had a 5 so that I could cancel out those 5's, and then I would have just plain x. But if I'm going to divide by 5 on that side, I need to divide by 5 on this side. And x equals 4. Okay, the last one is the division. Right now, k is getting divided by 2. And so just like we did in the purple example, what do you wish you had on the top? So technically you are multiplying by 2 on the top, and those 2's cancel out. So when you see something getting divided by 2, you think, I wish I had a 2 on the top so I could cancel it out. But if I'm going to put a 2 on the top on this side, I need to put a 2 on the top on this side. So you're multiplying by 2. All right, there are all the operations. And here is the difference between the expression and the equation. So an expression could be something simple like 25y. It could be just a number, 15. It could be 3x plus 5, just a chunk of number. It has no equal sign. It's not an equation. You can simplify or you can evaluate an expression to find an answer. Like you can make it, like I could say in this example, substitute a 2 for x. So, okay, so I can solve this chunk and know what that expression actually is representing. So it's kind of like a phrase. It's incomplete, whereas an equation is a sentence, mathematical sentence. Now it says that they're both an arrangement of mathematical symbols, may contain variables, numbers, operation symbols. So remember, your operators are your plus, your minus, dividing, multiplying. And maybe an equal sign could be considered an operator as well. The variable is the letter. Now any number that is stuck being multiplied to the variable is called the coefficient. So the 4 is stuck to the x, it's being multiplied, so that's called the coefficient. And any number that sort of stands alone, doing its own thing, those are the constants. You don't hear this word very often, but you hear coefficient and variable all the time. Okay, so let's look at the examples of what an equation is. It is a mathematical sentence. So here's an example. 3x plus 5 equals 20. You could actually solve for that. You could subtract 5 from both sides and get 15. So we're going to subtract 5 on this side. We're going to subtract 5 on that side. 3x is equal to 15. So 3 is getting multiplied by something. Gee, I wish I had a 3 on the bottom. And now it cancels out. Wish I had a 3 on the bottom of that guy. 15 divided by 3 is 5. Okay, so an equation can actually be solved. There you go. And it definitely has an equal sign. All right, good luck with equations and expressions.